that last video. I know it was kind of long, but we did cover quite a bit of ground too in that opening exercise. I want to go ahead and discuss then general strategy for graphing a quadratic function in standard form, which is really the point of this lesson, or at least that's what the title indicates, which we didn't really talk too much about in the previous questions. So general strategy, just like with vertex form, right? The vertex is like the key point. So we want to find the vertex. That's our first step, and then plot it. Okay, in standard form though, we're not told explicitly what the vertex is. Remember, standard form is y equals ax squared plus bx plus c. So what do we do? Well, the x coordinate will always be x equals negative b over 2 times a. Once you find the x coordinate, then find the matching y coordinate. Okay, by plugging in, or plugging the x coordinate into the function. Okay, it's a lot of steps, but that first step is crucial. Once you have that, normally what I do is have my students then make a table with the vertex in the center. So like XY chart, put the vertex right here, and pick some points before, and then pick some points after too. Plug those x values in, find the matching y values. You can use your graphing calculator to help you with that, with all those little calculations and stuff. And then you can plot those points. From the table. Okay, you still may need to calculate important points, like the x-intercepts or y-intercepts. So keep that in mind too. Okay? All right, let's take a look here at an example of that. So a high school baseball player throws a ball straight up in the air. Hey, this sounds familiar. The math class was able to determine that sounds really familiar. Okay, could be modeled by negative 16t squared plus 96t plus 6. Good gracious, this is the exact same equation, isn't it? It is. Wow. So what do you notice about the equation? Just as it is, that will help us in creating our graph. So right away, from before, right, we already know that the y-intercept is going to be 6. Because again, you can just plug 0 in for the x values, or in this case, the t values. Okay, we can also find the vertex x coordinate. Is x equals negative b over 2a, right? Where in this case, that's going to be negative 96 over 2 times negative 16. Like so, okay? Which again, we know simplifies to, what did we say it was up here? 3. Oh, my goodness, I didn't remember that. Okay. Can we factor to find the zeros of the function? No, we cannot. Okay, remember we tried that. If not, solve h of t equals 0 by completing the square. No, we're not going to do that. Okay, we did that already. We used the quadratic formula, and I think that was easier than completing the square. Sorry, directions. All right, so we already have that there. You can review that. All right, but again, we got the 3 plus 5 root 6 and the 3 minus 5 root 6 over 4. Okay, remember this plus 1 was approximately 6.1, and the other one was approximately negative 0.06. Okay. which we'll use to find the vertex. Well, since I didn't complete the square, I'm going to have to use standard form. But if you did complete the square, then you would want to use the completed the square version because that would be already in vertex form. For symmetry, so again, the axis of symmetry, remember, is the x-coordinate of the vertex, which we already know. It's 3, right? We said it was 3 right up there. So again, we're not going to worry about completing the square. All right, so let's go ahead and graph this thing. Okay, so this is really strange. They put the x and the y-axis, or the x and the y-axis in the center of the graph like this, because truly it wouldn't make sense to talk about a negative x, or negative x and y, or negative y and positive x's. So what I'm going to do is kind of like go a little rogue here, and we're going to like make our y-axis here and our x-axis here, because I think it just makes sense. All right, don't need any more of that. Put that back. Okay, so now we'll get this thing graphed. And so what should be on our x-axis? Time. Okay, and we already know that we're going to hit the ground back at 6.1 seconds. So I'm going to try and make this a little bit nice. So let's see here. Maybe I can count by like 0.2s. So 0.2, 0.4, 0.8, 1. 2, 4, 6, 8, 2. 2, 4, 6, 8, 3. 2, 4, 6, 8, 4. 2, 4, 6, 8, 5. 2, 4, 6, 8, 6. Well, that was maybe not the best choice. Maybe I'll count by quarters. Okay, let's do that. Quarters. So 0.25, 0.5, 0.75, 1. 1, 2, 3, 2. 1, 2, 3, 3. 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 3, 6. Okay, there we go. And then for the height, well, the maximum height, I think we figured out what the height was, right? Maximum height, up here we did 150. Okay, so let's see here. Maybe I can count by 10? No, let's count by 5. So I think we can do that. So we'll say 10, 15, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. That's fine. 120, 130, shoot, 140. All right, maybe I'll just count by tens. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220. Okay. Whew. And I lost my line, so now I got to redo that. Okay. So let's plot some of these points here, right? We already know the initial height is 6, so that's going to be like down here. Okay, we also know we're going to hit the ground at 6.1, so like right around in here. The vertex you also know is at 3, 250, I think we said, right? 3, 150. So 3, 150. So let's see here. There's 160, 140, so 150 will be right there. So that's nice. We have our axis of symmetry that goes through here too. Okay, so let's see here. Interesting. Okay, and let's see, do we have any other points? I don't think we do. So we can just like plug in some. So I can just like plug in 1, for example. So at 1, oh my goodness, I'm going all over the place here. So I plug in 1 here. We'll get negative 16 plus 96 plus 6. So I just plug in 1 for t. 86. So 1, 86. So there's 80, 90 be there, so 86 be like right there. Let's go ahead and do 5 as well. And we also get 86 at 5. So 5 is also 86. Okay, and I'll just connect these dots. That's enough points. And there's our graph. Okay, voila. All right. I think that's all we had there. All right, we'll go into exercise 1 in the next section.